All right, so I had a talk yesterday, you missed it, but so today I'm going to talk not about Passbolt, the open source password manager, which we are building with my friends here, Kevin, Clayton, and Shmuti. I'm going to talk about passkeys because I have the chance to participate and be a FIDO Alliance member and sit and participate to the plenary conference and the CPSIG. You will see FIDO, they love acronyms, so it means Credential Provider Special Interest Group, so because we are a credential provider. So what is authentication? Just so that everybody knows a little bit what we are going to talk about. Authentication is something you know, or something you have, or something that you are, like biometric, or something you do. Like you can even have like behavior-based authentication. So authentication these days is generally a combination of one or two of these factors. You know about passwords, and password-based authentication have a lot of issues. So you have like issues of the user selecting a weak password, or basically people being able to brute force, or like phishing is a big one, and you have all sorts of other issues. Generally, you can implement countermeasure to make sure that basically your authentication is good enough, but phishing is the one that is really hard to solve because it depends on the user. So you can solve, for example, password strength selection by introducing a credential manager, and you can prevent a little bit of the phishing with a credential manager, but you still, have some room there. So who has set up passkeys as a user in the room? Well, quite a bit of people. Who have, as a developer, implemented either Authenticator or like implemented passkeys authentication on the website? Yeah, 3 people. So we can see here that it's still a new topic. So what is a passkey? You will see that passkeys mean different things for different people. So I'm going to try to give you like a 10,000 feet view of passkeys and not like go too deep into the protocols and the options for the protocol or particular implementations, but just give you like a high-level view of the landscape, something that I would have liked when I started working on this because it's like really tentacular and there's a lot of options and a lot of different views. So passkeys, the official definition is passkeys are password replacement. They are public key, private key pairs that are used for authentication using cryptographic signatures. So basically you have like a site that gives you something to sign, and you sign it and you prove that you're you using an authenticator. Passkeys are user credentials that are discoverable, so it's possible for the browser to know if you have a passkey for a given website, for example. And because in the browser the JavaScript is served by a website, it means that the website can also discover whether you have credentials. So these passkeys are stored within application or security keys, and they may be synced across devices. So this is the new stuff. We've seen in the previous talk that we were talking about device-bound passkeys, the passkeys that are sitting on devices, but there are now a new class of passkeys that can be synced across devices. So you can see this is the lay of the land. Like depending on like who you ask about passkeys, they will tell you maybe they are like thinking about device-bound passkeys, so passkeys that are on physical devices. Or if you ask Google and Apple, they will talk about sync passkeys. And sync passkeys are basically keys that can be synced across multiple devices. So you can, for example, have them on your laptop and on your phone, or you can basically transfer them or like do an attestation using your phone while you're trying to authenticate on your laptop. And these passkeys are supposed to be exportable and transferable, but in practice, they are only transferable within a given ecosystem. So, for example, Apple will not let you export passkeys to Windows, for example. So they are advertised as being like, interoperable, but because they are not coming from the open source world like we do, like interoperable for them means different things. So there are also another class of passkey, which is called app-level passkeys, which generally have lived with the device-bound passkeys, and meaning that they can be used for other things, or you have like additional properties added to them. So typically you'll see them in banks. So for example, like a bank application will use passkeys to sign transactions, or they will use additional signals to unlock a passkeys, something that is not there with a classic authenticator. For example, they will check like your location or like your working hours. Like you can do all sorts of different signals. And you can build a custom authenticator. So like you can build like the UI that you want. You don't necessarily have to follow like the OS or like the physical device design. So there are a lot of different requirements. We've seen like basically passkeys means a lot of things. So like on one side you have like people that are working on the enterprise level. So people that want hardware keys that are like very strong and you cannot export them. And on the other side, you have Google and Amazon, for example. They don't really care that it's very, they want the frictionless experience. So they are ready to trade a little bit of security for usability. So for example, when you're doing a checkout using Amazon, they want you to go as fast as possible through that checkout and pay. And even if there is a security issue, they will be okay to give you back your money. But if you do that with a bank, they are not like having the same mindset. So on one hand, you will have like passkeys that require certifications. The banks will check, is it the authenticator that I gave you to authenticate? Is that really your personal device? And on the other side, you'll basically have like website like Google that just want to show like, okay, you authenticated with the YubiKey, but they don't really care like which one it is. It's just to present you like, okay, you have these passkeys and this is the kind of authenticator that you are using. And on the enterprise side, they will issue, for example, for like super high security setup, they will issue you like a security token that is just for you. So you can see that this has some privacy implications. So for example, if everyone was using like a device that is unique for each of us and we log in on the on each website with this device, you will be able to do cross domain tracking. So you'll be able to see like, okay, this guy logged there and then he logged there, and this is a privacy issue, obviously. So on this side you want privacy, on this side you want basically no privacy because you're in an enterprise setup. So all of these are like very complex requirements and they're all fitting in the same standard. So basically like it's a little bit complicated to know like what's going on. And but the common denominator is phishing resistance, the fact that the passkey is domain bound. So like you have one passkey for Gmail, one passkey for AWS, but you don't reuse the same passkey twice. And it's always supporting HTTPS. They made this choice, which is very wise. It's like no support for HTTP. So the FIDO2 project is a project that works with the FIDO Alliance. FIDO Alliance contains like Google, Amazon, Visa, but also like Thales, people doing like security devices. And on the other hand, you have like the WebAuthn protocol, which is managed by the W3C. So you'll see like basically people working on the FIDO Alliance are also part of W3C. It's the same people. For example, the person at Google is the same on both projects. And together, this is called the FIDO2 project. So on one side, you have W3C that manage the WebAuthn protocol. And on the other side, you have FIDO Alliance, which manage the CTAP, which is client to authenticator protocol. So basically, the relying party is the website you're trying to authenticate to. It uses WebAuthn over HTTPS. Then you have the client, which is basically your browser and the JavaScript application that is running in it. And you have the authenticator. So authenticator can be the OS platform. It can be like a device, can be like a YubiKey, it can be anything that is basically FIDO approved. And these days, it can even be a credential manager. So it can even be like a Bitwarden or Dashlane or 1Password. And the interface for client to authenticator is a bit more messy than WebAuthn. Basically, you have like it works with Bluetooth. It works with what everybody calls monkey patching. So basically, if you want to integrate in the browser in JavaScript and become an authenticator, for example, as a password manager, you will just hijack the JavaScript API and like replace them with what you want. So that technique is called monkey patching. It's the only way for a browser extension, for example, to act as an authenticator. But you have like also proprietary protocols. For example, like when the Google Chrome browser wants to use the Google Authenticator, you don't know what's happening underneath. They are using their own stuff. So I hope that's clear and gives you like a high-level view of like what we're talking about. So there are two ceremonies. There is the attestation ceremony, which is the registration, and there is the assertion ceremony, which is the login. So there are no other operations. So for example, you cannot list what are the passkeys available for a given relying party. You cannot delete passkeys. These are not part of the protocol and need to be implemented separately. Like it's not normative. So we will see that this causes some issues. So the attestation ceremony, you have the client, which basically posts a username. So this part, post a WebAuthn attestation option, is not normative. You can do whatever you like. As long as you send a username, basically the URL doesn't matter. So it's for the relying party to decide what is the language that it wants to use, what is the URL. So recently they introduced a WebAuthn.wellknown file that you can place on your web server to basically say like, okay, this is my attestation URL. Then the relying party reply with the public key credential creation option, which includes the RP, which basically the ID of the relying party, the challenge that the user needs to sign, and some other options. Like for example, we've talked in the past, in the previous talk, people were saying like, do you check for user presence? Do people have to enter a PIN? This is basically the moment where the relying party can say like, okay, I want to use this algorithm and I want to check the user that way. I will require user presence. I will require you to do user verification. And then the client does basically what he wants. So from that, the client calls the Navigator Credential API. There is not a WebAuthn API. Basically, we use a JavaScript API, which is the Credential API. Which can be used for other things, but it's used mostly for the WebAuthn protocol these days. And then we basically enter a CTAP protocol or something else. So either like a proprietary protocol, but here I put CTAP for like clarity because it's the one that is the most defined. So same, you will send some data about the RP and the user, and the authenticator will assert the parameters, see if the crypto operation is supported. So it's asking to use a particular type of key. Can I create such keys? Then collect the user gesture, so like either enter or enter the PIN, and then generate the credential and generate the signature. It will return the attestation statement and the authenticator data. And the client will send this information over to the relying party. The relying party will assert if the key is valid and will check the signature, is it valid for that particular key, and it will check if the RP ID is also matching, so that basically you don't have a client that uses another request from another website. So we keep the property of having a domain-bound process. So the assertion ceremony, I'm not going to detail it again, but it's pretty much the same thing, except you're not like giving the new public key. You're just signing with a key that is already there on the authenticator. And then what about account recovery? So obviously, if you lose your device or you lose your passkey, then what do you do? So there are two types of account recovery. There is account recovery for the RP. So basically, they had like the solution to passkeys is more passkeys. So it's good if you have like a device-bound passkeys, because then you need to buy more devices. It makes a lot of sense when you're selling devices. And you can also use passwords. So generally, you have like a website like Amazon. They will let you have a password, but they will propose you to have passkeys on top. So basically, you will default to passkeys, but you can still use your password for account recovery. And magic link. So basically, passkeys are as good as the account recovery mechanism. So we're kind of back to square one. Unless you get rid of these methods for account recovery, you're not like really changing your security posture, in my opinion. And on the authenticator side, it's a little bit more complicated. Apple recommend you to have several Apple devices. Makes sense. And then you have you can also set recovery contacts. And you have a custom procedure. So I give you, like, for example, what happened on iCloud if you lose all of your devices. And it's actually possible to do a recovery from iCloud using all your devices, and it's quite smart. I must say. The problem with we have in open source world is we don't have such a service that is ubiquitous where people have an account. So for example, if we are Ubuntu and Firefox, we don't have such infrastructure to exchange such escrow mechanism, and that's going to be a challenge, I think, moving forward. So how does it look like from an authenticator point of view? It's a work in progress, and there's a lot of change. So like maybe like by the time I put this slide together, it's already updated. This is an example on macOS and Chrome. And so you will see on Chrome, by default, Chrome will prompt you to use, when you click continue, it will use the Google Authenticator. So you have the impression that you're using the OS level authenticator, but you're actually using Google Authenticator. That is leveraging the API of the OS to provide an experience. But it's not the Google Authenticator, it's not the Apple Authenticator. So you can see already it's already kind of sneaky, because like if you're using Chrome, they will prompt you to use the Google Authenticator. But you have some other options. For example, you can use the phone or a security key. So basically, you see there is more clicks if you want to use something that is not Google. And then you will scan this or press your security key, and you will have the same result. So if you can even do like two device ceremony, where basically you scan this QR code, and then you will unlock your phone, and the signature will happen, and will be exchanging through Bluetooth BLI. So there is no pairing with the laptop and the phone, and you will be authenticated using that mechanism. So it's possible, for example, to use like an authenticator on Android phone to log in on a Windows device using this mechanism. So if you use Firefox, you will start directly using the Apple authenticator, and it's the same if you're using Chrome. You'll see like basically if you use that option that was there on the previous screen, then you switch authenticator. And for me, like I don't expect like people that are not like knowledgeable to understand what's going on, you know. So, and it's the same, like depending on like the options that are provided by the RP, you may have like different mileage and different user experience. So it will be quite confusing, I think, for the average user. So it's the same if you want to manage your passkeys. They are like buried, so it's really hard to see like how many passkeys do you have and where they are registered. Same on iOS. If you want to manage your passkeys, you need to go to passwords. So it's like, you need to click on the password to see that it's a passkey. So passkeys are like, okay, we've solved the password problem. We can all go home, right? Like that's it. Mission accomplished, as George would put it. But no, we still have a lot of issues to solve. Like we have like what happens when you lose devices, especially when you don't have like a sync fabric that is common to different authenticator. And there is no real work being done on passkey management and review, as we have seen. So for example, in the future, we have seen with the previous talk, with quantum computer coming soon, we will need to roll out new algorithm. Maybe we will need to change algorithm faster than we had in the past. So we will need to revoke keys. So in order to revoke keys, we will need to design experience where the user understand, okay, this key is using an old algorithm that is not supported. You need to create a new passkeys. So we will need to have a user experience to manage passkeys that is understandable for the average Joe, which is we are very, very far from there. And it's the same like for developers. I think like for developers to understand all the different options and what they mean when you're implementing as a RP, it's quite tentacular. And you, for example, you can't follow the implementation of Google because Google does not care about user enumeration on because you can already send an email to a Gmail address and it will bounce. So you already have user enumeration in place. So they basically don't implement best practices to prevent user enumeration. But for your use case, maybe it's important. So like you can't even follow like what the big players are doing. You will need to do your research and find out. And I think this can lead to some problems down the line. And we will need to do a lot more of education on like what are the security problems around passkeys. There are some other issues. As you've seen, like the user experience is quite fragmented, and it will not be the same on different OS and different authenticators. And there is an entry barrier for authenticators. So like we're one of the few open source projects on the FIDO Alliance project. It costs around 50K a year to be in the room when these things are being normed. And so it's basically like a pay-to-play initiative. And in my opinion, for something that is supposed to replace password, which is so ubiquitous, that's an issue. So we even have, like, I think Firefox have a seat at the FIDO Alliance, but they didn't have the staff last year to be there. So I think it's an issue. And there's a lot of proprietary protocol and monkey patching happening, and like we need to do much more normalization. So I invite you to get involved and to be interested about this, because if you don't act on it, basically they will make the decisions for you. That's it. Do you have 5 minutes? Yes? All right. Yes?
The complications that you just mentioned to implement it, is this also true for somebody, let's say, a software as a service that wants to offer passkeys to their users?
Yes.
Do they also have to deal with all this complexity, or is there maybe a simpler way?
Yes. So do the RP have to do their homework to understand the issues around passkeys? Yes. Okay. And they are not like super easy to get. You know, like for example, if let's say you're building like a service like that authenticate people using passkeys, but it's like a globalized service for your enterprise, and you're doing just one passkey authentication on that domain, and then you're switching to another protocol. Maybe you're using an iframe, and in the case of passkeys, you may have issues with UI redressal. So you need to basically take care of these issues. And so these are like, you need to read the specs. And I think maybe there will be more education and more easy resources. And I think we need like how-tos like for developers on like, not for them to trip their feet on. And same like what kind of algorithm you should support. Like we've seen there's a lot of legacy websites. Like maybe like they start creating keys with a certain algorithm, but 2, 3, 4, 5 years down the line when quantum computing becomes like something that you have to do because the state is telling you have to do it. Then, you know, what happened with these keys, you know, like...
You said earlier that kind of the relying party can say the user must be present, for example, in certain things. So how does the relying party know that the client actually ensured that?
So how does the client ensure that the authenticator is doing what the RP is requesting? I think it depends on the option, but most of the options are basically like, for example, the client can ignore that the user needs to be verified, but with the data that will be sent back, as part of the assertion, you will have, okay, what did the authenticator do? Did he verify the user or not? So it will be the RP to verify. Say to the client, I want the user to be verified, and when he has the response to say, did the user get verified, yes or no? So you say, I want this, but you need to check if it actually happened when you get the final assertion. Make sense?
But you have a password manager, so somebody says, please make sure that the user is present, and you sign the challenge and say, oh, I said the user is present, but you actually lied, because you're the password manager. You can do that.
Yes.
So there's no way for a website to know that the password manager is trustworthy.
Yeah, that's where the FIDO certification come into play. Like, but it's like nobody wants to be like, you know, caught off and like say like, hey, look, they are, you know. So it's also like a gentleman agreement that you're gonna respect and do. But I could suspect like that some, you know, people that are like do-it-yourself kind of thing, they can make their own authenticator that does whatever they like. Yeah. But for example, a bank may refuse to use an authenticator that is not FIDO certified. Like, so, you know, depends also on the RP.
Because can you assert which service are you using for attestation when the OAuthn API is called? So on your response, do you know who certified that?
Yes, so you have information. So it's like in the response, do you have information about the authenticator? Yes. So you have information which is high level, which is what they call the AA GUID, which is basically a global UUID that says like you're using like a YubiKey 5, but you also have like older version of this where you have like actual certificate and you have like a signature that so this is stored in the MDS. Of the FIDO Alliance. So if you are like, for example, a bank and you want to make sure that, it's not somebody pretending to be a YubiKey, you can actually see the certificate, the root certificate, and check against that assertion. 1 minute. Does it make sense? So you have two levels. You have one which is like the user agent kind of thing that most are using, but you have another one which is like more complex that involve like cryptographic and signatures.
We've seen some examples with Apple ecosystem and Chrome, but what about Unix-based system implementation? Is there anything like passkeys for private key authentication?
On the Unix system, basically, like to my knowledge, not much is happening. I think there is a talk with GNOME. The GNOME team is going to present like what's happening on the Linux side, but it's way behind in terms of like Microsoft Hello, Apple Keychain, and Google. I've not seen an open source one, but you have like credentials manager, like for example Bitwarden or Dashlane, that are basically can bridge the gap in an ecosystem where there is no OS level support. Thank you very much. Hi. Hi.